Okay, so we're going to continue our discussion on normal distributions here. And we're going to look at problem 619 here. And notice here we wanted to find a probability between some certain values. So what we're going to look at now is we're going to go backwards. What if we were given the area and then we want to find out what those cutoff values are? There we go. So I'm going to just change this up a little bit. So what is a cutoff for the 90th percentile? And if you recall, whenever we say the percentile, we're talking, that's the cutoff where we say there's that much percent below us. So if we say the 90th percentile, we're talking about that there's 90% below and then 10% on top. So our mean is going to be 68 here. And there's our cutoff here. And we're saying that there's 10% on top and then 90% on bottom here. And since we actually said the 90th percentile, we're talking about the bottom 90. So that's going to be the region that we're our shading here. And so the question is, we're going to want to go ahead and find out what this cutoff is. So this is going to be math exam scores. And I'm looking for this specific value right here, right? What score would I need so that I'm above 90% or I'm in that top percent here? Okay. So we want to get the area or the probability. If you recall, those are going to be one and the same here. So to get the probability, we use our normal CDF function. Well, now we're going to go backwards. And so in order to go backwards, we're going to use this idea of an inverse normal CDF. And in our TI, it's actually a TI inverse norm function. And I'll show you guys where that's at. I also posted a video for it. And so here's going to be area to the left, your mean, and then standard deviation. So this is the way we always input it. And make sure that you're paying attention to that. It's area to the left always. So it's always going to want to be this region that's right up in here. So inverse norm, we're going to put in 0.90. We're going to plug in our mean, which is 68. And then our standard deviation here is going to end up giving us 3. And if we plug that into our calculator, that's going to end up giving us a value of 71. So we're really using the tables backwards. So right here, what we're really doing now is we're going backwards. We're kind of given an area here. And then we're trying to work our way backwards to find out what exactly is that specific z-score. And then from that, we plug it into a formula to actually get what our x value is. So there's using the tables, and then we're doing a bit of algebra working backwards in this case to figure those out. Okay. And so we'll get 71.84. So what is a cutoff? What is the cutoff exam score for the top 25%? Now this one is phrased in terms of the top 25%. So I'm still looking for my X cutoff right here. But when I go to shade my graph, I'm going to want to shade the top 25%. So that in there is going to be 0.25. Because the question is phrased in terms of that area. And I'm always going to want you guys to make a sketch, right, then figure those out. The sketch is going to be very, very helpful. And so that means we have 0.75. So again, inverse norm, area to the left. Now you recall, that's going to be the complement of that 0.25 there. So it's the difference to get to 1. Your mean is still 68. And then our standard deviation is going to be 3 in this case. And if we plug that into our calculator, that's going to be 70.02. So we need about a score of 70. And for that top one, just to clarify, probably about a score of above 72 or so. Okay. All right, let's see another one here. Okay, I went ahead and fast forwarded that. So if you want to pause this and try to answer this question here. Okay, and so notice this is talking to standard normal. So whenever we say standard normal, that means we're talking z-scores. So mu is 0, sigma is going to be 1. Always. It's always going to be the case whenever you see standard normal. So mu is 0, standard deviation is 1. And we want the 30th percentile, so that means we're looking at the bottom 30% there. Okay? So that's going to be the bottom 30%. And the question is, what's our z-score in this case? So we want to find out what this specific z-score is going to be there. So again, we're going to use an inverse norm because we're working backwards. And it's always going to be area to the left here, which is 0.30. Our mu is 0 and our sigma is going to be 1 in this case. And that gives us about 0.52 in this case, or negative, 0.52, since we're to the left of the mean. It's about half a standard deviation to the left. Okay, so if you want to pause it here and try this next one. All right, so now we want the cutoff here, and we want to do it for the top 5%. So again, to this phrase in terms of the top, that's going to be 0.05 there, and we're talking z-scores here because we said use a standard normal. So that's inverse, and we want area to the left, which is going to be 0, 1 in this case. And how did we actually get this right here? Well, if you recall, that's the complement. So it's 1 minus 0.05 gives you the 0.95 in this case. And that's actually what we have. Here for this guy. And that's how we get that 0.95. Okay, let's keep going here. And so here's a question. So example 6.9 here. All right, so right smack in the middle again is going to be our mean of 2 there because there's our average. And so we're talking the units here are going to be x is in hours here. There's our standard deviation of 0.5. And then what we're looking is we want to find a probability between 1.8 and 275 in this case. So I'm going to mark those, and so 1.8 is somewhere to the left of the mean. 2.75 is somewhere to the right, just a rough estimate there. And I'm looking for that area right in between here. Okay. Now note, this time I want to find the probability, which means I want to find the area. So we're going to use a regular normal CDF. Okay, so we're going to use a normal CDF, and it's always your lower, your upper, your mean, and standard deviation. So 1.8s are lower, 2.75s are upper, our mean is 2, and our standard deviation is 0.5. And we're just going to plug that into the calculator. We don't even have to convert it to z-scores to look up in our table. Our calculator will just work with whatever values we have in this case here. That's going to give us 0.5886 in this case. And so what if I wanted to label the graph with the z-scores? So we technically don't need them because we're not really using the tables, but it's worth knowing how to get those because when we start doing hypothesis testing, that's going to make all the difference there. So if you recall our z-score formula here, if we plug in our value, so we're going to first do it for this 1.8 over here, minus the mean over the standard deviation. That tells us that this guy is going to be negative 0.4 z-scores. And then I want to do the same thing for my z-score, and I'm calling it lower and upper z-scores here. I'm just labeling that probability there, but okay, let's go on here. So 2.75 minus 2, so I'm doing it for this guy now. and I'm finding out what his z-score is, and that's going to be 1.5 in this case. Oops. All right. So when we look at this x-axis right here, you could think about it in terms of two ways. Actually, three ways. This value right here, right, we could think about it in terms of the actual units we're talking about, so hours. It also corresponds to a specific z-score there. Or we could talk about it in terms of the probability, the area up to that value as well. So when we look at our normal distribution, think about it in three different ways there. The area, the actual units, and then again in terms of the z-scores. And being able to go back and forth from those is going to be very, very helpful. Okay, so let's try another problem here, and I'm just going to write those in there. So here's another question, and if you recall from the binomial distributions, they wanted us to use some specific notation, which was the binomial, then your number of trials, and your probabilities. Well, for normal distribution, we're going to do the same thing, and it's really just a way for us to always denote what our mu is, right here, and what our sigma is. We're going to be plugging it into normal CDF and the inverse normal, so we don't really need to worry too much about this notation here. That's just what's standard for this text and WebAssign here. Okay, so suppose that the distance a fly ball hits the outfield, normally distributed with a mean. So there's our mean of 250 and standard deviation of 50 feet. So this is just a way for us to make sure we're picking out the information we want there. Okay. And so let's look at part B and then part C. And if you guys want, you guys could go ahead and pause it here, try it on your own before I get involved. Okay. So there's our mean. And here we're talking feet for our x. And then the standard deviation is 50. And so we want the probability that x is less than 220. Okay, and notice I'm using x because I am talking about feet in this case. So 220 is somewhere to the left there, and I want it to be less than that. So the part that I'm going to shade is going to be lower than that 220. So I'm going to use a normal CDF, and we always put our lower. And if you recall our lower here, if we keep going this way, negative infinity lives that way. And all we're writing this guy here is negative E9 is a compact notation for us to write negative 1 times 10 to the 9th, which is technically negative 1,000,000. Which is a very, very small number. So that's the way our calculator uses that. And if you recall, it's going to be second comma right above the 7 to get that E. Our high is going to be 220, so I'm looking at the shaded region. That's why it's always nice to do that shaded region first. There's my mean, and then there's going to be my standard deviation. So lower, upper, mean, and standard deviation there. I'm just going to adjust that right about there. Okay. So there's our probability that we get less than 220. And again, up to about 4 decimals. Let's look at part C here. We want to find the 80th percentile. So now we want the area. I'm sorry, now we're given the area and we want to find out our cutoff. So 250. We're talking x in feet, and we want the 80th percentile. So percentile always talks about the bottom portion. So this is the part that we shade here. Sigma is still 50, and now we're going to use the inverse norm. And if you recall, it's always area to the left when we plug this in. Then your mean and standard deviation. So 0.80, 250, and then 50 there. And if you plug that into your calculator, you're going to get about 292.08. So roughly about 292 feet or so. That's going to be the specific x value. that ends up being the cutoff for that 80th percentile.